Hello YouTube, this is Chester with STEM APKs. Welcome to another tutorial. In this tutorial, we're going to continue where we left off in the last tutorial. If you remember, in the last tutorial, we were able to load the images and do the scale bar. And let me open an image first. This is what we did in the last tutorial. And we were able to choose scale bar and then drag and then show the scale legend, which show you how to do that, and that's why you have the dialog. Okay, in this tutorial we're going to take it a step further, and we're going to, besides, it's going to be a lot more intuitive. So what we're going to do is going to open an image, and then we are going to be able to open it. But now it has this new calibrations tab, and it has a guide that actually tells you what to do. It gives you the instructions to follow. It tells you this tool helps you to calibrate your image for accurate measurements, tells you to draw a line, enter the distance, and the objective, and the export. Okay, so you start calibration. It tells you to click and drag to draw a line along a distance in your image. So in this case, we have this stage micrometer, so let's do the best we can here, because normally you would have a zoom to zoom in into the line. I haven't added it yet, but now we gives you, it's more intuitive. Is that you can put the image naming here. You can show the scale legend just like we did before. You see the legend there. We put the distance. This is a stage micrometer. Let's call it just 1000 microns for simplicity. This 1000 microns, 5x objective. Okay, so I'm gonna change objective. It gives you these nice hover instruction. So you add the objective. It stores the data for the 5x objective, and then you do it again for the next objective, right? So that was 1000. So now let's do, if you were using a microscope, this would be a different magnification. So that this, let's say, would be, just keep it simple, keep the math simple, just by half. So this would be, let's say, 500. So let's do 500. This will be 10x objective. And add another objective. So that's 500. So we'll do close. And now we'll do it again. And now let's do half again. So let's say 250. It's not going to be exact. This is just a proof of concept. And again, we'll do 250 microns. And then this will be the 20x objective. We're assuming this is a microscope. This is how you would be calibrating an image. Get the image coordinates with the screen coordinates with the stage micrometer. So that will be add objective. Yes. So now we're almost done. So let's do 125 now. There'll be more or less here. And this one will be 125 microns. And then this one, let's call it 50x objective. And one more to go. This is why you have this small scale and the micrometer. Now we're assuming that this will be magnified to 100x. So now it will be 62 more or less. So it'll be, that's 50 microns. So let's just do it there. Like I said, I don't have a zoom. Normally you would zoom in to be exact, but this is just proof of concept. So that will be, let's call it 62.5 microns, and this would be, let's call it 100x objective. And now you're done. So you say finalize all. Tells you, it gives you a choice to keep editing, close, or export. I'm going to export. And now I go to export report. You name the report to, let's call it hello YouTube. And it gives you a choice of a CSV file or a Markdown. Actually, you can put PDF. You can do anything right there by just changing it and adding to the cargo toml file. But I just keep it simple. Just we'll go with CSV, comma separated value. So let's go with CSV. Then go save. Calibration report was exported successfully. And now you can find it, and it's right there. Now you open it, and there it is. You have this nice report that you can keep with your report. And the most important thing, if you're using a microscope, you will see that it's more or less half. So that half of this is more or less half of that, more or less half of that. It's not going to be exact, but it's just a proof of concept. But if you look at the scale, is pretty close. I mean, it's not exact, but it's pretty close. Okay, and that's what this code will do. It could be very handy for certain applications. And now I'm going to show you how to do that. So let's get into the code. Basically, I have a couple files here. I'm just gonna do clear first, just to get it out of the way. And let's do a git status. This is just to give you an example of all the files that have been modified. They were not modified by a lot, just a little. I just want to give you, I'm going to put this in the GitHub so you can do a git diff and look at the differences of what it was modified. These are the new files that I created, and some of them were modified a little bit, some of them are more than others, but these are the new files. These were existing files that I modified. So let's just clear this, and these are the files here in green that I created. These are completely new. So the first one is this one, calibration report, and I'll just explain the code to you because this is new. Basically here we're bringing the standard path, which provides a way to handle file paths in a platform independent way. We worked with Certainly before. This works together with, if you remember from the cargo toml file, it's right there. So it works with JSON, and you can also do it for YAML files. And we did that a few tutorials ago. So this is, we're using it again to serialize and to deserialize images. That's not the one. This is the one. We did it again. This one. So this is why I'm bringing it here. Chrono I'm using also from toml file. We used it before. This gives you the time. It gives you the universal time coordinate UTC time. And we're bringing the crate from layers metadata, which is this guy right there. And we're bringing calibration, and we saw that in the last tutorial, I believe. And we're bringing this guy. This implementation here, it gives you the date, the image, the objective, scale ratio, and notes. And if you look at the report, that's exactly what you see here. Okay, image, objective, and let me just, so you see, and you see here image timestamp, image name. I didn't put in the image name, but you can put it there. Objective, pixel distance, real distance, whatever is in the micrometer, the real distance. This is the screen distance. The unit that you're using, you can change it. You can be using microns. If you're doing microscopy, most of the time you're going to be using microns, but sometimes you will use nanometers if you're doing laser confocal microscopy, or you can be doing millimeters if you're doing stereo or stereo microscopy or things like that. This is the scale ratio, the unit, and here notes. It gives you that choice to add there. That's what that is. That's where that's coming from. And we go back to the calibration report. So this is what this is bringing right here. Here is using the SERD, serializing is basically here is importing the calibration struct, which is going to be having all of the calibration data in that vector right there. And the UTC is just going to be importing the calibration. It's going to be the calibration timestamp basically, and you used to get the current universal coordinated time. Okay, this is the implementation block for the calibration report. It's going to have the constructor for the calibration report is going to have it's going to take a vector here of the calibration on as input, and it's going to set a export date to the current time that is using UTC now. So it's going to be whatever time is being used. That's what's happening here. So we continue down. This is going to export the calibration report to a CSV file. Basically, that's where that is happening there. P is a generic type that must implement the OSREF path, and it's going to allow you to change whatever path it is, right? It's all working with the standard input-output, and it's going to give you the result. Here is going to create a CSV writer for the specified path. And this operator right here is just used, it's for error handling. It's almost like error E. It's just a way to propagate error. Here is going to go through iterate. It's going to iteration. It's going to write the header row for the CSV file and give a column name, just like we did in that report that I just showed you. That's what's happening right here. It's going to write the headers. It's let me just show you some close there. These headers are being created. You see these headers right there? That's where they're coming from. And we continue. This is just writing the data. Is the iteration. Here is the headers. This is the iteration with the basic, the real information on it. Basically, it's going to iterate through the calibration data, and it's going to write everything into a CSV file. This is converting the timestamp to ISO 8601. This has to do with the UTC, with the chrono library. Here is extracting a reference. So if it finds that the image you didn't put a name, it's going to default to unknown, as I showed you before. Here is going to just add the respective calibration data, doing to all the pixel distance, real distance, unit, just that are what I just showed you. Here is going to ensure that all the data is written to a file, and this is just saying to indicate successful execution. Here it comes down. This is for CSV. This is for CSV. This is for Markdown. And if you had PDF, you would also have PDF here. Right now, I just have CSV and Markdown. And basically, is same thing with same thing that we did there, but here is exporting the calibration report as a Markdown file, and it adds the title and generated date to the Markdown report, and it's using human readable format, so it's easy for humans to read. This is the for loop that is going through, is an iteration through all the calibrations and the formats, each one for the Markdown section. Okay, and here is basically just writes the Markdown content to the specified file path, and just content and path, and is using the file from the standard library. Okay, so that's going on. And now we here going to the mod.rs. It's just modules, just letting it know where to find this stuff and what is using from that the reporting directory. Here's the UI. It's bringing the FLTK usual suspects here for the scrollable area, the pack. This is what this is doing here. When we do, is this the right one? No, this is the old one. Let's close this one. Let's use the good one, the latest one. And it's this one, and then open image. Let's do this one. So when you open the image, and then let's say that you tell it that you want to do a calibration, is open the calibration welcome dialog. Here I didn't go into here. This is for thread safety, the arc. Here the atomic boolean is also covering, is related to this, the arc, and I don't want to get into that right now. Maybe we'll get into that in a couple tutorials. We'll be getting deeper into this stuff. I don't want to go down that rabbit hole right now. If we continue here, as we go down, here's open the calibration welcome dialog. It's a 400 by 400. It's going to have, let me just show you, image calibration label, default color, as you can see, it's the same color. We've seen that before. Here we just basically, let me see here, it's doing the calibration, color background, the arc, it's bringing the stuff from atomic boolean and ordering. For now, let's not go into that. This is adding the scrollable container. It's a 10 by 10 spacing. It's a 380 by 330. And it's going to have the main vertical pack. And it's going to have here the title, image calibration guide. It's this right there. Color foreground. It's a 360 by 25. This has the description. This is what's going on here. This tool helps you calibrate your image for accurate measurement. This is where that's coming from. And align left, align it can, you have a choice to put it where it's going to be. This is the steps for all these steps right here. That's what that is. And here is the same thing, default backend. This is where it ends, the scrollable area. Back. These are the buttons. Start calibration button, 180 at 40. Position, size, label. Always remember, position, size, label. There's this one right there. Cancel is right there. Color light 3, just lighter color. And now the buttons that call back. This is the closure that when the start button is clicked. So let's say that I click on it. Now it brings this guy where it gives you more instructions. And it's going to either keep the window open, waiting for you to do something, like now, waiting for me to do something, or not. So it's gonna be open. So remember, it's going until you do something. This is a while loop, and it's gonna keep showing the window. And then final proceed. This is the end. If to basically the end of this section, right? Until you decide to do whatever you want to do. If you want to do start calibration, and then you do, let's say you do the image, and then you say 1, and now you here you have a choice. You can either finalize all, export a report, you can finalize. This is what's happening here. So basically that's what it does. So I think this could be handy in many applications. You can export, and you can play around with this. You can tweak it to your own particular application. In this case, this is more for calibration of images. I wanted to do something that I can calibrate my own images, and that's why I created it. But like I said, it can be tweaked to many applications. It's up to you. You can. I'm gonna put this in my GitHub. You can get it there, and you can do whatever you want with the code. And this is the end of this tutorial. If you like this tutorial, please click the like box, subscribe to my channel, and I will see you next time with another tutorial. Take care.